Good day. We are the Group 2 and our topic for today is about circle graphs. Here's a short introduction about circle graph. A circle graph, commonly called a pie chart, visually displays data in circular sections. Each section represents a distinct category or group, and its size reflects the corresponding quantity. These charts are popular for showing percentages or proportions within a whole, simplifying complex data for quick comprehension. These sections or slices represent specific parts of the whole dataset, with the entire circle encompassing 100% of the data. Their straightforward layout helps convey comparisons and trends within a dataset.
Circle graphs or pie graphs were invented by Scottish engineer William Playfair in 1801. In the statistical breviary, he used the circular diagrams in order to recognize the sizes of various economies of countries. In the late 1800s or in the early 20th century, Florence Nightingale, founder of modern nursing, gained popularity for using pie graphs amongst the British soldiers during the Crimean War, showing the causes of their deaths. Nowadays, pie graphs are used in a wide range of fields, mainly for data visualization.
A pie chart, also known as a circle graph, displays data in a circular form with segments representing different proportions of the whole. Its resemblance to pie portions is why it's often called a pie chart. This graphical tool offers a straightforward way to illustrate the relative proportions and distributions within the dataset. Each segment size in a circle graph corresponds to its portion of the total dataset, aiding in understanding data distribution and facilitating comparisons between categories.
Definition of terms. Sector. Each segment of the circle represents a category or subset of data. These sectors are proportional in size to the corresponding data values they represent. Central angle. The angle at the center of the circle that corresponds to each sector. The size of the central angle is proportional to the percentage or proportion of the data it represents. Sector area. The area of each sector determined by the central angle and the radius of the circle. Larger data values are represented by larger sectors. Total frequency or total. The sum of all data values being represented in the circle graph. Legend or key. A box or section of the graph that provides labels or explanation for each sector, typically showing what each color represents. Title. A descriptive title that provides an overview of the information being displayed in the circle graph. Radius. The distance from the center of the circle to any point on its circumference. In a circle graph, the radius helps determine the size of each sector. Percentage. The proportion of the total frequency represented by each sector. It is often displayed alongside the sector or in the legend or key.
Making a pie graph has several steps. The first one is to collect data. Gather the data you want to represent in the pie graph. Ensure the data is categorical and that the total sums up to 100% or 300 degrees. The second one is to calculate percentage. Calculate the percentage of each category by dividing the value of each category by the total and multiplying by 100. The third one is to draw a circle. Draw a circle to represent the whole data set. This circle represents 100% or 360 degrees. Next one is to divide the circle. Divide the circle into sections proportional to the percentages calculated in step 2. Each section represents a category, and its size corresponds to the percentage it represents. The next one is to label sections. Label each section with the corresponding category and its percentage if needed. Next is to color sections. Assign different colors to each section to make the graph visually appealing and easier to understand. Next is optional. Add a title and a legend to clarify the meaning of each section. Lastly is to review and finalize. Double-check the accuracy of your calculations and the clarity of your labels before finalizing the pie graph.
For sample problems, sample problem number 1. Nursing faculty conducted a study to understand the distribution of common causes of patient falls among elderly residents. What percentage of falls were caused by other factors?
To find the percentage of falls caused by other factors, we first need to calculate the combined percentage of falls attributed to environmental hazards, medication side effects, and mobility issues, which is 35% plus 30% plus 20%, a total of 85%. Then, we subtract this combined percentage from 100% to find the percentage of falls caused by other factors. So 100% minus 85% is 15%. Therefore, 15% of falls were caused by other factors.
Sample problem number 2 is a nursing research team conducted a study to investigate the distribution of causes of readmissions among postpartum women within 30 days of discharge. What percentage of readmissions were caused by other factors?
In sample number 2, to find the percentage of readmissions that were caused by other factors, first, must subtract the percentages of readmissions attributed to postpartum hemorrhage, pre-acamphlesia, and postpartum infection from 100%. To find the percentage of caused by other factors from the chart first, we have to include 45%, which is the postpartum hemorrhage. The 25% is attributed to pre-acamphlesia, and 20% is the postpartum infections. So we're going to add it all up. It is 90% subtracted by the 100%. It is equals to 10%.
Interpretation or answer. For the sample problem number 1, therefore 15% of falls were caused by other factors. While for the sample problem number 2, therefore 10% is the percentage of readmissions that were caused by the other factors.
For conclusion, pie charts are a widely used visualization tool, offering a clear and concise way to represent proportions within a dataset. They are particularly effective when showcasing relative percentages or distribution of categories. However, their effectiveness can be limited when displaying too much categories or when precise comparisons are necessary. Despite these limitations, pie charts remain a popular choice due to their simplicity and ease of interpretation, making them valuable assets in various fields including business, academia, and data analysis.